Hello, the following is Team 2's proposition for a research module as well as its components aboard the Lunar Gateway.
Hello everyone, my name is Amelia Anderson and I'm majoring in aviation flight and management, and I'm going to tell you about space weather. Space weather directly affects aviation because it can control where and when we fly, particularly in the polar regions. According to the American Meteorological Society, space weather is the conditions on the sun and in the solar wind, magnetosphere, ionosphere, and thermosphere that can influence the performance and reliability of spaceborne and ground-based technological systems and can endanger human life and health. As our dependence on complex, advanced technology increases, so does our vulnerability to space weather. Space weather is a global-scale phenomena which has demonstrated the ability to disrupt high-frequency radio signals, satellite-based communications, navigational satellite positioning and timing signals, spacecraft operations, and electric power delivery. Space weather can also present an increased health risk for astronauts as well as aviation flight crews and passengers on transpolar flights. These disruptions can cause cascading socioeconomic effects. The estimated cost of an extreme space weather storm could reach up to $1 trillion with a potential recovery time of 4 to 10 years. Here you can see the solar radiation scale provided by the Space Weather Prediction Center, and you can see the range of effects depending on the severity of the storm. Compared with meteorology, space weather predictions suffer from both a lack of observations and limitations of even the best available space weather models to describe the complex phenomena involved. Most responses to space weather are based on current conditions with limited advance notice. This is why we need more research to go into space weather so we can have more advanced predictions, especially for bigger storms. The advantage of having sensors and imaging systems on Gateway is that it will provide us with data we can use not only on Earth, but also for the future of space exploration. It is important to note that Earth's magnetotail extends well beyond the orbit of the Moon, and about once a month, the Moon orbits through it. This can have consequences ranging from lunar dust storms to electrostatic discharges. In short, space weather affects human health both on Earth and in space, communication systems, including GPS and radio signals, and recovery from a big event would cost a lot of time and money. We need more research in this field so we can better understand the sun, predict these bigger events, and protect human health. The space weather affecting Gateway will be the same weather affecting the astronauts that live there and in a base on the Moon. What better place to study solar radiation and space weather than from space, particularly in areas that we want to stay in the long run, such as lunar orbit on Gateway.
My name is Brock Bonin and I'm majoring in microbiology, and I will be talking about a microorganism supercomputer. The study of microorganisms is not a new thing. It has been occurring on Earth for a long time now, as well as on the International Space Station. Microorganisms play such a large role in our everyday lives and constantly surround us. They have many different effects, from helping with water treatment to causing people to get sick. As seen in the picture, the area for microorganism research is rather small and limited to one person at a time on the International Space Station. Other hardware for microbial research on the International Space Station includes Wet Lab 2, Razor EX, Minion, and Mini PCR. There needs to be a larger area for more advanced technology for microorganism studies to be carried out. Microorganism research is currently conducted by humans, but with my proposed technology, a portion of that research will be able to be conducted by machines and technology. This is new because it wraps a lot of tests up into one and allows for more of the research to be automated. Microorganisms are forms of life, and thus can prove that life does in fact exist on another planetary body outside of the Earth. These microorganisms can also make it easier for humans to inhabit that specific planetary body. They can perform tasks in areas such as water treatment. These microorganisms can also hold the key or be the cause of a disease that might come about in the future. This technology will consist of a lot of different forms of technology. All of them will help with the identification of different microorganisms. On this slide, a sizing scale, culture locker, and DNA sequencer are all displayed. My proposed technology will consist of all of them. The sizing scale and DNA sequencer will all help with the identification of the microorganism. The culture locker will provide an adequate environment for the microorganisms to thrive and survive so the quality research can be done on them. The technology will also include a database with every known microorganism in it. This will allow the microorganisms found to be compared to the ones on Earth. If it isn't like anything on Earth, the microorganism will be added to the database so it can be later identified. Along with being added, further testing on the microorganism will be done to better understand it. Due to the amount of technology and machinery needed for this, the budget is about $1.5 million. This proposed technology has many advantages which are all listed. As mentioned before, it is automated and can perform multiple tasks. This will eliminate the need for different sets of equipment. It can also compare its findings to known microorganisms to better classify it. Lastly, it can help grow the microorganism so future studies can be done. Technology like this will be perfect for future space missions. This would be huge for missions to other planetary bodies and to answer the question of whether or not life exists on its surface.
My name is Anuj Pawar, majoring in zoology, and I'll be discussing the microgravity science glove box component aboard the module. So another feature that we would like to have on our research module is a microgravity science glove box, or abbreviated into MSG. Now, to be specific, this type of glove box is not like the one that you would have for your car. This is more for scientific purposes. Now, the word for microgravity simply means in a very weak gravitational environment, like in this case, a space station. What the MSG is it's basically a sealed container that's used to separate samples from the external environment, or vice versa, separate samples, or separate an individual using the module, testing with samples as the samples are in an internal environment. This type of device is also used on the ISS, International Space Station, and on Earth, a simple science glove box is used to protect moon rock samples from the external environment. As we can see, there are two different types of science glove boxes. The one on the left is the one that would typically be used on Earth. It has a purge valve, front-mounted light. It has a touch screen to make any adjustments necessary to the device. Large antechamber where you would put in the sample initially, and then it would go into the main chamber. Gas purification system so that the environment inside the device is different from the environment on the outside. Typically, what scientists would do is use nitrogen. On the right side is the one that would typically be used on the ISS or in any other space station. Has air filters, glove box, airlock, control monitoring panel. Typically, these devices would take up from top to bottom the entire height of the port or the module. So the purpose for an MSG, as stated before, is that it separates samples from an external environment. It also provides extra protection for the researcher or for the scientist that is using the module, because typically scientists would or researchers would use the module to research with liquids, combustion or hazardous materials. It allows for easy access for small or medium-sized investigations, and these experimentations can vary from any field of study with biotechnology, combustion science, life science, anything else that has to do with space or science in general. Many of these experiments, again, use liquid chemicals, materials that can burn, can be hazardous if it was placed out in an open environment, which can be very hazardous for astronauts.
Hi, this is Renee Davis, and I'm a computer science major. I'm going to explain how our research module will utilize technology to keep research projects going, day or night. As you all likely know, astronauts will only be up in the Lunar Gateway for 3-month periods of time. That means there's plenty of times where the Gateway might be left to orbit the Moon deserted and empty. With the use of artificial intelligence and robotics, this research module can keep making discoveries 24/7, astronaut or no astronaut. By constantly utilizing the module's functionality, we can make great use of the equipment we spent millions of dollars to send into lunar orbit. Not to mention, NASA's astronauts and researchers can direct their time towards making discoveries rather than tediously gathering data. For those who don't know, artificial intelligence is all about giving a computer human-like qualities, especially decision-making. For our research, we can focus on a subset of artificial intelligence, machine learning. Machine learning is a process by which you can teach a computer to analyze and identify data. First, computers are given a set of data and pre-drawn conclusions to teach it how data will be classified. After this teaching period, the computer can then start to take in new data and draw its own conclusions. As it interprets more and more data, it gets better and better at classifying it. In our research module, machine learning will be put to use in forecasting space weather and analyzing microorganisms. For example, the AI that works with space weather would first be taught how to identify things like solar winds and flares. By taking input from space weather research sensors, it can eventually start to predict these events, giving us a better chance to prepare for possibly catastrophic events. As previously mentioned, the AI used to analyze microorganisms could be directly implemented into the special equipment that Brock has proposed. The AI software integrated into both kinds of research will be able to detect anomalies and important findings that can then be reported back to researchers. This notification system would free up a researcher from having to constantly watch over the sensors and machines. With solar weather and microorganism research automated, next up is any research happening inside of the microgravity science glove box. In order to continue research without human presence, we need something that can precisely interact with the materials inside of the glove box. A perfect solution is the 6-axis robotic arm called Mecha 500. This arm is fairly lightweight and small enough that you can hold the base in the palm of your hand. Its a small size and ability to make precise movements enables it to move around inside the glove box with ease. No matter the kind of research taking place inside, the arm can be customized to fit the research needs. Research can design customized software and specialized attachments that can be 3D printed in the gateway to fit the arm. Not to mention, this arm can be controlled by a wide range of operators. It could be controlled by astronauts on the gateway as an assistant, or when the gateway is empty, by researchers back on Earth, or by the module's AI itself. This robotic arm would obviously need to be paired with a camera if it is to be controlled by anyone other than the astronauts on board. This camera is crucial for navigation as well as capturing pictures of testing results. In fact, photographs taken both in and out of the microgravity science glove box can be used by the AI to create virtual reality content for astronauts and researchers. Through the process of photogrammetry, software can turn a series of pictures taken of an object into a 3D model. This GIF here shows a chocolate bar that was photographed and turned into a digital 3D model. You can see just how detailed this process can get. Now imagine if we used it on things like lunar rock samples. Scientists both on and off Earth would be able to virtually interact with an object no matter how far away it was. The AI can also use data gathered from the module's many research projects to create 3D data visualization for researchers to interact with. Using an AI to determine the most important data and display it graphically can save time and easily keep scientists up to date with findings in the research module.
My name is Quinn Bennett. I'm studying psychology and criminology/criminal justice, and I will be talking about virtual reality. Virtual reality has many uses while in space, such as helping prevent mental illness due to loneliness, helping astronauts explore other planets before reaching their destination, and using VR and other robotics to help control them to fix technical issues that could be extremely dangerous for humans to attempt. To start off with is mental health. Something we are all now learning is being stuck in the same place with the same people is getting old and boring. While we do have the luxury to pick up our phones and chat with someone else, astronauts do not. One easy solution to this issue is virtual reality. VR has already been shown to help many other patients suffering with anxieties and fears. Associate editor at The Wearable writes in an article, How VR Will Stop Astronauts Getting Lonely and Bored on Their Way to Mars. Explains how Dr. Jackie Ford Morey, a VR pioneer who has been working in the field since 1989, has been drafted to keep our spacemen and women connected to their loved ones and the ground crew, as well as be ensured they stayed entertained and mentally robust as they hurtle towards another planet. By having VR, this will allow the mental stability of astronauts to combat the illness that could come from loneliness, such as depression, anxiety, and addiction. Next is the exploration of planets. VR has already been used to help train astronauts. According to spacecenter.org, explains the virtual reality laboratory is an immersive training facility that provides real-time graphics and motion simulators integrated with the tendon-driven robotic devices to provide a kinesthetic sensation of the mass and interior characteristics of any large object being handled. As this has already been provided to help astronauts learn in the beginning, they will already have an experience and would allow them to understand the planet and how it could be before arriving. Since NASA already has a rough idea of these planets and knows the planet's atmosphere is, astronauts would get a better understanding of their destination with VR. As astronauts are the only people while on their journey, if there is any need for repairs, they are the only ones to do that. They do have precautions to allow everything to go smoothly. However, there is still a significant amount of danger when it comes to completing this task. The answer to reducing this danger is telerobotics, which is defined by NPA.org as a robot controlled at a distance by a human operator, regardless of the degree of robot anatomy. This would allow them to control the robot to fix the issue while using VR to observe the issue without any danger.
Here you can see the estimated cost for the equipment for our research module. You can see that the space weather sensors are going to cost about $1 million, the microorganism analysis computer is going to cost about $1.5 million, the MSG is going to cost from $30,000 to $50,000, the robotic arm is going to cost about $15,000, and implementing virtual reality is going to cost about $1.2 million, bringing our total to $3.8 million. These estimates are based off of existing technology. This has been Team 2's proposal for a research module aboard Lunar Gateway. Our module includes space weather sensors, microorganism analysis, a microgravity science glove box, and implements virtual reality and artificial intelligence. We believe that this module would be highly effective aboard a space station like Lunar Gateway. Thank you for taking the time to listen to our proposal.